Hi, this is Coach Chuck of the National Free Flight Society Youth Development Program. Today I'll be presenting our coaches seminar for the 2024 to 2025 Science Olympiad flight event, which is helicopter this year. This presentation is available in this video as well as in PDF and PowerPoint format on our website if you prefer to present it yourself. We'll discuss the event and the rules. And then as an add-on, we'll discuss sources of material, sources of help, building techniques, and flying techniques. The helicopter event is a pre-build event where you build the helicopter ahead of the contest date and test fly it and perfect the flying and then bring it to the event for competition. It consists of a rubber-powered indoor helicopter flown strictly for duration, and that helicopter is made with any materials except for boron fibers. Similar to the airplanes last year, the helicopter will be presented in a box with the outer dimensions specified. This gives a lot of freedom of design as long as the completed helicopter ready to fly will fit in the box. The event will consist of 2 flights, and your best flight will be your score. Kits are permitted, but the kit must be student built. The changes from last year, obviously the big one is the change from any aircraft, helicopter, glider, or airplane, to helicopter only. There's a slight change in the box dimensions depending which class you're in, and the box dimensions are the same for both the B division and C division. The motor mass, the rubber band, if you will, is unlimited, but the aircraft, the helicopter, must weigh at least 4 grams. A little bit of direction on the helicopter event. It is not a design event, although the box outline approach leaves a lot more design possibilities on the table. But this is primarily a flight optimization event. Get yourself a helicopter that works and spend the time flying the helicopter and learning how to make it fly more. Data collection and recording is critical to your success. You've got to know what worked and what didn't, and what trends took you in the right direction. So while a log is required to get bonus points, I believe it's critical to your success in this event. Build light. I can't stress this too much. You want to try and reach the minimum allowed weight. Some of the kits will tend to build a little over the minimum weight, and this is because they don't necessarily have the ability to select the best wood for every kit they send out. The helicopters, even more so than the airplanes, depend highly on the weight of the craft, and saving a quarter of a gram could be tens of seconds of flight. So very important to build lightweight. We'll talk about that a little in the building. It's also important to build accurately. The rotors, as they spin around, are essentially wings, and if they are built crooked and don't match each other, then your helicopter is going to wobble all over the place and waste a lot of energy just trying to beat up the air rather than flying. So accurate building using the fixtures in the kits is important. I already mentioned the importance of taking data. You want to take lots of data, and that means you need to fly a lot. This year with the helicopters, you don't necessarily need a gymnasium to fly in, so there's no excuse for not flying a lot. Let's look at the parameters of the helicopter. A kit is permissible, or a self-design, or a coach's design, published design online. Anywhere you get a design, including a kit, is acceptable, but nothing can be pre-glued or pre-covered. The finished helicopter must fit in the specified box, ready to fly. The team can buy a box or build a box. Only one box is required per team, and they call that the measurement box. And this box can hold both helicopters or one at a time for measurement, and it can double as your shipping container. Both B and C division have an exterior dimension of the box of 32 centimeters by 24 centimeters by 47 centimeters. So there's no difference between B and C this year. An 8-ream paper box, not 10 reams, but 8 reams, will fit within these dimensions. It'll actually be somewhat smaller than these dimensions, but it will fit the rules. Or you can build your own box. But be certain that when you put the helicopter in the box, that it fits completely within the box, and that the shape of the helicopter does not change. In other words, say the rotors don't bend in order to fit it into the box. It's up to your team to verify the box dimensions. Just because you have something that says 8 reams of paper doesn't mean it's a legal box. So measure your box, make sure it fits the rules. Don't push the dimensions. Now, I didn't see many boxes that were purposely trying to get right up to the maximum dimension and went a few millimeters over. Rather, I saw a lot of boxes where people simply weren't cognizant of the required size, and they might be 10 centimeters over in one dimension and 5 centimeters under in another dimension. Don't push the dimensions, but verify your box. Make sure it fits the rules or you will be tiered. Your students should be allowed to modify the box without leaving the competition area and without bringing in additional materials, but that's up to the event supervisor. The rotors, some people call them propellers, but they're not. They're rotors, must be student built. You cannot buy prefabricated rotors. In other words, you can't buy 2 plastic propellers, call those your rotors, and put them on a motor stick. The rotors must be student built. Up to 3 rotors. Most helicopters in most configurations will have 2 rotors, either top and bottom as shown on this picture, or a Chinook style where you have 2 on the top or 2 on the bottom adjacent to each other. There's no limit on the chord or the diameter or the number of blades of the rotors other than that which will fit in your measurement box. As with every other year, your device must be labeled for identification. Your best label is your school name, but the rules are not specific here. You have to have a label that differentiates it from other helicopters. Up to 2 helicopters can be presented for inspection. You can fly 1 or both of them, but no more than 2. And the rotor is an integral part of the helicopter, so spare rotors would constitute another helicopter. So be sure you have up to 2 complete helicopters, but any spare rotors should be set aside and not processed for check-in. The team during flying is a 2-student team. It can be done by 1 person, but it's up to 2 students. And I already mentioned this, any non-compliant aircraft or boxes will be tiered, which means your score, no matter how good it is during the flight, will rank below all of the scores from teams that their helicopter complied with the rules. A few additional event parameters. The helicopter must weigh at least 4 grams minimum without rubber attached. So you have to be able to remove the rubber for massing. The weight is critical, so you want to get as close as possible to that minimum weight. Has to be rubber powered. In other words, there's no such thing as a glider helicopter. The rules say rubber powered, and so if there's a rubber band on there that functionally does nothing and the rotors can't turn except for the whole thing as you drop it, then it doesn't fit the rules. It must be powered by rubber. There's a requirement for a dime-sized disc of balsa being the uppermost part of the helicopter, the part that will contact the ceiling first. And this is because older designs, such as the one here in the picture, with a stick on the top, sometimes would stick into a crack or even puncture the ceiling tile, and then the helicopter would stick to the ceiling, increasing its time. So they now require a dime-sized disc on the top, and right now the rules say that disc must be balsa. So be sure you comply with that. I mentioned flexibility of the design. The simplest design is something like shown here, where you have 2 rotors that are coaxial. That's 1 rubber motor to wind. This is the easiest way to make weight because it's a minimal of structure on the helicopter. You can have both rotors spin independent of the motor stick by having a prop hanger on each end of the stick, or one of the rotors can be fastened to the stick and the motor stick would spin with that rotor. If this is your design, you'll notice that the top and bottom rotors have twist in the opposite directions because they're powered by one piece of rubber, and so they're spinning in opposite directions. Both of them are lifting the helicopter. A Chinook style is allowed. This is where you have multiple rotors either on the top or bottom of the plane or of the aircraft, and these are not coaxial. And when the rotor size was limited, there was a certain advantage to doing this. You get more rotor area by separating two rotors. The box limitations may negate these advantages because if you have two rotors, both on the structure adjacent to each other, you're taking up more of your box, and it's hard to maximize your rotor size. In addition to that, you've got two motors to wind, and that complicates your winding process. When you only have 10 minutes to get off your two flights, that could be a problem. So the Chinook style may be something you want to play with if your team is an advanced team, but I wouldn't recommend it for basic qualification flights. The In addition, we already mentioned there's no specification on the rotor configuration, the diameter other than fitting in the box, the number of blades. You can have a 3-blade or a 4-blade rotor, however many blades you want, and whatever chord or width of the blade that you desire. So there's a lot of flexibility in the design. Okay, the flight log. This is a sample log that we posted on the NIFIS website. You can make your own log and use this as an example. A complete log is worth 20% bonus, so it's free points. Incomplete is 10% bonus, no log is 0 bonus. A complete log would have 10 flights minimum, and it has 3 required columns: motor size, and they don't specify what motor size is. That could be the length of your loop, it could be the width of your rubber, it could be the mass of your rubber. Any of those would qualify as motor size. So you use something as motor size that would be helpful to you in tracking your different flights. Second required one is number of turns or torque at launch. If you're unwinding your rubber after winding to max, be sure to report the number of turns or torque at launch, not your max. Your max could be a separate parameter, but the rules require the number of turns or torque at launch, and then the flight time of the flight. The additional columns, they ask for 3 as a minimum, more is better. Things to consider might be altitude, and that's going to be set by the size of the room because the way these fly is they go up and hit the ceiling and bounce around on the ceiling until the rubber runs out. So, but height of the room or altitude might be important to you. If you provide number of turns for your required entry, you could apply torque as your secondary column. Remaining turns or torque at the end of the flight. You can count remaining turns by putting the rubber back onto your winder and unwinding while counting. Number of unwinds before launch. You can really turn this rubber quite tight and you risk breaking your motor stick. So you may want to unwind a little before the flight, and you may want to record how many turns you unwound before the flight. If you're experimenting with various rotors, you may want to have details of your rotor, such as pitch, number of blades, chord, and so forth. The motor size parameters, only one of them was a required entry, but maybe 2 or even all 3 of those parameters are important to you. You can use some of those as additional parameters. And anything else that you have that is relevant. Now, I say here that it must be data parameters. The date and the flight number are generally not considered data parameters, so that wouldn't be considered one of your columns. But generally, it's got to be something that's measurable and or changeable. So your flight time or altitude would be measurable. Your number of winds are both measurable and changeable. Your center of gravity location on the helicopter is something that's measurable and changeable. So that's what I would use to determine if it's a valid data parameter. The log, as I mentioned, is critical to improving your flight. In the event, your flying process, it will be an indoor facility and the room dimensions are supposed to be published in advance. This isn't as big a deal for helicopters as it was with airplanes, but one of the things I want to point out is a smooth ceiling is highly preferred over a girdered ceiling. These helicopters will hang up on girders. You really don't want to be in a girder, Jim. Talk to your regional and state directors well before the event and point out that a girder gym is not a good place to handle this helicopter event. It would be preferable to be in a 10-foot high classroom than a 30-foot high girder gym. You could do racquetball courts, ballrooms, foyers or hallways that have a higher ceiling. Ideally, you'd want to see something 20 feet or more, but you can do it in a 10-foot or even an 8-foot ceiling, and that would be preferable over a girded ceiling. Um, Once the kids enter the competition area, whether for testing or for competition, they cannot have any communication or coaching. That means no cell phones, no yelling, no visual cues back and forth. And it says once the competition area is cordoned off. So even if they open it up for practice in the morning before the event starts, the coaches cannot go in there with the students and coach them. Only the participants can touch either the helicopter or the box. Don't let the officials attempt to measure or mass your helicopter. The students need to do that. The flight log, we mentioned 20% bonus, so be sure to bring that with you. It must be presented to the judges. They don't have to ask for it, though they usually will. There's a 10-minute clock. The judges will take your rubber motors at check-in and they will hand you your rubber motors and start a 10-minute clock. All flights must start within that 10-minute clock window. There's no timeout for retrieval or repairs. Any flight that starts within the 10-minute window may go to completion. You can't get another flight after that, but if you start your second official flight at 9:59 and it's a 3-minute flight, that's great. You go to almost 13 minutes as long as it got off before the end of the 10-minute window. Trim flights are permitted within this 10-minute competition window, but they must be announced as a trim flight. If they're not announced, they're assumed to be a official flight, and they have to be announced before the launch. The score is your best duration of the two official flights multiplied by your bonus. So if you have a full log, you'd be multiplying by 1.2. And construction violations are tiered as usual. Some of my experience and observations from being an ES at various levels, the biggest one is insufficient logs. Um, Too few columns is the big thing. Meaningless columns, such as having the date and claiming that that is one of your data points, that happens a lot. Fewer than 10 entries. These you can fly anywhere, so not having 10 entries is just not using your log to learn from. You're just trying to meet the requirement. Um, so get your logs, keep them, complete them, and you really ought to have dozens or maybe even hundreds of flights in your log. It's okay to present just 10 flights, but show some variation. Don't just take 10 that were all your final configuration, because then none of the parameters are changing, and what have you learned from the log? So if you're going to show a subset of your full log, take a selection that shows you actually use these parameters to vary some. Accurate construction is critical. I see a lot of poorly constructed aircraft. Too much glue. I've seen some models where they're built from a kit that can easily built to close to weight, and yet they come in weighing 20 grams due to immense amounts of glue using hot melt glue or just using gobs and gobs of super glue. Glue is heavy, a lot heavier than the balsa wood and covering of these kits. So be sure you understand how to use your glue and how to minimize your weight in gluing. Not flying the same in practice and competition. I've seen too many times where kids have practiced one way, repeated it, got their process down, and then the team ahead of them puts on a killer flight, and so they go in there and they overwind it and launch it in a way that they didn't practice, and the helicopter or airplane dives straight into the ground, or the helicopter veers to the side and hits a wall. Um, if you're going to go for it in the contest with a massive wind, make sure you test massive winds. Don't let your kids be intimidated by the next kids over. Incorrect box size is a huge one over the last few years. You're responsible to verify your box is legal. I've had kids show up 2 years in a row with oversized boxes, and they have to sit there and repair them and make them legal or be tiered. And then the next year they show up with another box that's too big. So be sure you verify that your box size, outside dimensions meet the rules. Some of the thoughts for improving your game here with helicopters. Um, Spend more time in testing than you do with building. Yes, it's a pre-build event, but testing is where you learn to fly, you learn to maximize the use of your rubber. That's the real place where these helicopters can differentiate themselves from the other competitors. Keep detailed logs. More columns is better than less. It's not just a requirement. It's a good idea if you want to improve. Read and follow the rules carefully. Understand the rules and meet the rules. So many times a team gets tiered because their device or their actions don't meet the rules. There are plenty of resources. The online forum at Scioli will put you in touch with people like myself and Coach Brian, as well as other competitors, and they're always more than likely to help you. The National Free Flight Society continues to develop resources and videos. You can find us at the link here. The QR code will take you to the same place. And we are in the process of developing additional resources for Heli. Some of them have already been posted, and we'll continue to post things throughout the year. So keep an eye on those locations for help. If you want help, the forum is the best place to post. If you direct message myself or Coach Brian, we'll probably direct you to post it on the forum so everybody can benefit from the answers. Unless there's something like a video that gives away a secret design, there's really no need to be secretive about asking questions. So with that, that covers the event parameters and the process of the event. I hope you enjoy the season, and I look forward to seeing you online and in the competitions. In the next sections of this presentation, if you choose to move on, we're going to look at sources for materials and kits and sources for help, as well as a little bit of building and flying hints. This is not going to be all inclusive. We're not going to walk through a build here, but hopefully can put you on the track as coaches to find the resources that you need for your students to excel. First thing is, where can I buy kits? We strongly recommend you start with a kit if you've never done something like this, or even if you've done the airplanes. The helicopters are different enough, and there's some good kits out there that will get you in the right direction. Once you've built a kit, you can look at how you might improve by doing a custom build, but the kits are usually well thought out. Let's start with Ward Science, kind of the obligatory kit supplier. Their kits over the last few years have been very limited in terms of a complete design. They're more open-ended than the other kits. They're a bundle of glues and sticks and covering and so forth, rubber, to get you started, but don't give you a whole lot of direct design and guidance. They're not as refined as some of the other kits. They have not yet announced a Heli kit for this year. I'm sure they will, but there are other options that are more directly tied to the helicopter event. The next one is Freedom Flight Models. They've been supporting Science Olympiad for at least 10 years. This picture is of their 2013 helicopter kit. The Freedom Flight Models tends to be a little bit complex compared to some of the other models. but it's a very complete kit. This is typical of their kit. They're showing fixtures for building. The top fixtures are for building. The bottom fixtures are for covering of the twisted rotors. Very complete kits, and Dave Ziegler puts a lot of effort into high quality kits, and his kits are usually very competitive, usually in the top 10 at nationals. So Freedom Flight models, their helicopter, the reason I've got a 2013 kit here is they have not released their helicopters yet. He was doing final development after the rules came out to make sure the helicopters meet this year's rules. And as usual, his kits will be available in early October. He also has a full stock of accessories such as torque meters, winders, counter for the winder, rubber, propellers, which isn't applicable this year. J&H Aerospace is a little bit newer in Science Olympiad, but they've been very successful in the last 5 or 6 years, I believe, maybe longer. Josh and his wife Hope head up the company, and Josh is a very competitive indoor flyer, and he is very supportive of youth development and Science Olympiad, and puts out some very nice kits. He did have some pre-rules helis based on the Summer Institute guidelines, and these were sold. So it's up to you as a team to compare these to the published rules. I don't believe there were any changes to the kits once the published rules came out. So I think you're okay there. But if you bought a pre-rules helicopter, it's your responsibility to make sure it fits the rules. Josh has two versions. The Tornado is the top one here, and that's with built-up rotors. That'll build to weight, and it should give some very good times. The second is the Twister in the bottom photo here. The Twister has sheet rotors. It's a lot simpler. My understanding from a couple of other coaches that have bought these is it will build in less than half an hour. So it's a quick build. It's not going to get the times that you get with the Twister. It's not going to have as many things you could tweak on it. But if you're looking for something simple that will get you a time that's more than just a rock dropping to the ground, which we see a lot of, unfortunately, in helicopter, the Twister will build fairly close to the minimum weight, and it will fly. So that's a low cost, low effort option. But if you want to be competitive, you're going to be looking at the built up version. Josh puts out a lot of YouTube videos, and I should say he always has two versions of his kits, a simplified lower cost version for more basic teams, and then something a little more complicated for the advanced teams. So good on Josh to be supporting the entire spectrum of Science Olympiad competitors. He also has a lot of building and flying tools and supplies, and his link is there on the image. Laser cut planes. I'm showing airplanes here because he has not yet put out the helicopter kit, but I have talked to John, and he plans to put out a kit. John McGrath is an educator. He understands students, and his planes, at least, have always been simple building and good flying for a very low cost. He uses interlocking laser cut pieces, very good photo instructions, and his planes, at least, build without plans because they're self-fixturing, self-jigging. So he's known for very simple assembly. Be looking for a heli kit probably sometime in October. Guru Engineering is fairly new, probably 6 or 8 years now, so not entirely new. They're a nonprofit organization. I believe they're out of West Virginia. He does laser cut kits, and again, he's aiming for very easy to build. This is his prototype for this year. I don't know how much the kit has changed from this prototype, but it features a very simple assembly. His kit builds two helis plus two spare rotors, probably one top and one bottom. And he has detailed instructions with photos. So Guru Engineering. And then finally, Retro RC. Now, I have not got a response yet from Retro RC. They have done very well with their airplane kits. They're not one of the mainline Science Olympiad suppliers, but their kits have always had some really unique features, such as the biplane shown in the lower picture. They've not announced a helicopter kit on their website, and I have not received a reply back on that. So check with RetroRC if you want uh, something that should be very competitive and maybe has some features that the others don't. That might be a good option. The other way you can do it is with plans. The National Free Flight Society has put together a plan designed by a very well-known AMA flyer, Academy of Model Aeronautics, Dave Ehrenstein. He was flying helicopters at the AMA Nationals and was asked by our president to develop a helicopter kit based on his, not kit, but design based on his approach and with a simple construction in mind for the entry-level flyer. So if you look over these plans that we've published, and it's a top image here, you'll find there's only two different sizes of balsa, except for the balsa disc up top, unfortunately. Um, but there's only two sizes of balsa stick. He's tried to keep the sourcing simple by doing that. And it's a fairly straightforward with straight blades, so you can build them flat on the table instead of having a helical twist. The lower picture is the River City rocket. This is a a plan from 2011, I believe. This is just an example of what an X-rotor would be. The advantage of the X-rotor is both spars are attached to the pivot point, and so it makes a very strong structure. Um, and this River City rocket plan, since it's from 2011, may have to be adjusted a little bit to fit in the box for this year, but it shows you how simple a X-rotor style helicopter can be. The final plan we have linked on our website is Jim Richmond's AMA helicopter. And this is just there for interest and to learn what the ultimate end of these helicopters can be. It's a record-holding design, less than a half a gram. So completely different class from the 4-gram Science Olympiad plans. But it's possible you might glean some ideas and you might enjoy looking at that. So we posted that, and I think we posted one other AMA helicopter design on the resource page. Accessories are important, winders, rubber, torque meters, covering, prop hangers, all that kind of stuff. All of these people provide it. Indoor Free Flight Supply doesn't have any kits, but they excel in both entry level and high level tools and equipment. Freedom Flight Models, we already mentioned, they have a good supply of support tools, and they have a very nice twisting element torque meter. FAI Model Supply, primarily for prop hangers and for stock rubber sizes. And by stock, I mean 3/32, 1/8, 3/16, and so on, bulk rubber. J&H Aerospace, Josh and Hope Finn, have a very nice website with lots of support tools. Again, some very entry level up through advanced stuff. RetroRC has a good selection of winders, torque meters, and so forth. Valari Products has covering, prop hangers, winders, and so forth. Indoor Model Specialties, Ray Harlan, tends to support the higher end models such as F1D, but you can get their rubber stripper, prop hangers, covering, and that kind of thing. You can go to their website and it'll say it's down for COVID. He is supporting people through email, but he's not brought his website e-commerce package back up. You can find plans on Hip Pocket Aeronautics. The owner of Hip Pocket Aeronautics died about a year ago, and they've struggled to recover the site and get it back up to its former glory. But the plans library is there, and you can look for old plans and so forth. And then the Free Flight Society, I already gave you a link to that. We have some plans online. Other resources, we've got them at the Free Flight Society, videos, plans, how-to guides, help sessions, and so forth. The Scioli online forums is important because it's an archived record of questions being asked and help being given. So They tend not to have too much fluff at those. So that's a good place to ask questions, and a lot of high-level coaches will be around to answer questions. Um, Hip Pocket has a forum for Science Olympiad. It's not well attended since they had their issues, but I'm hoping that comes back. They're still waiting on recovering the old information. A couple of videos. Well, there's a PDF here on minimizing weight gain. I think that's a good read. There's a companion video to that I put together on our website. But this minimizing weight gain is talking about how to prevent gaining too much weight with your glue. And there's also a document here on the Science Olympiad website on basic building techniques. And again, how you strip wood, how you minimize your weight, and so forth. So that covers where you buy the kits, where you get help from, and that kind of thing. Your go-to site for help is going to be the freeflight.org Join, Learn, Fly Science Olympiad site. That will branch to all these other sites. Let's look a little bit about building techniques. Weight is everything. We already said that, and weight can be most easily controlled through glue control. I like to use thin super glue or cyanoacrylate with a capillary applicator. So you squeeze a little bit of glue onto some wax paper, or I use a margarine lid, and then use the capillary applicator, which is just 2 pins and a scrap of balsa, to apply a very small drop of glue to your joint. Now, this requires that you have a good fitting joint to begin with. If your joints aren't so good, you could use medium cyanoacrylate and apply it using the tip of a toothpick instead of the capillary applicator. But the medium, they call it gap filling. If your joint is not strong to begin with, meaning good contact, you're going to be filling the gap with glue, and the glue is more brittle and not as strong as the balsa wood. Balsa density is important. If you're going to do your own design, weigh and grade your balsa. You can calculate your pounds per cubic foot, which is how we normally grade balsa, by weighing the whole sheet on your gram scale and then calculating the density of the wood. I bring my scale to the store whenever I buy balsa. If you go in a Hobby Lobby, you may not find any lightweight wood, or you may find one sheet out of the whole stack. If you're going to a local hobby store that specializes in model aircraft, you might find a better selection of wood. You may need to order wood, and the best source right now for full sheets of wood suitable for Science Olympiad would be specialized balsa out of Colorado. Indoor Free Flight Supply sells indoor wood. These are smaller sheets of high precision wood, generally aimed at your microlight AMA birds, but he may have some stuff that would be useful to you as well. Heavier wood than 5 to 8 cubic pounds per cubic foot may be used, say, for the spars, but the uses on it are limited. So you definitely want to stay on the 5 to 8 pound per cubic foot range, maybe approaching 8 pounds for the spars and approaching 5 pounds for the ribs. Motor stick is probably going to be 6 or 7 pound wood, and go from there. The kits tend to have very good wood. You might do a little better by hand selecting wood, but generally the kit makers are buying bulk quantities of very good quality wood, and there may be some variation kit to kit, but generally they strive to have usable wood. You need to build straight. All of the kits come with fixtures that you can build on. If you get a foam board, say a 1/2 inch foam board from Hobby Lobby, put some wax paper on that and a pin through the wax paper, through the plans, and onto the board. Sometimes you can glue that foam board to a shelf surface, like a laminated shelf from Home Depot. In some cases, glass can provide a building surface, but you can't pin the glass. But you do need something flat and straight to build on. Some of the kits have carbon, especially for the spars on the rotors. And carbon is light, it's stiff. It's not as light as balsa wood, but it's stiffer and less prone to breakage. But sometimes it's a little bit hard to get a great joint with carbon. So if you wrap a key joint with thread, and I'm talking 1 to 2 wraps around the joint, and then a dot of thin CA to soak the thread, that can bring a lot of strength to your joint without adding a lot of weight. So look for your critical joints and consider wrapping with thread. Covering, this image shows covering of a wing, but the rotors are going to be similar. Your fixture may not be flat like the wing fixture is here. It may have a twist to it, but the approach is the same. This is ultrafilm. It's a very thin mylar film, and it's been crumpled up to a small ball and then uncrumpled probably twice to give it a kind of wrinkly look. And that's not for aerodynamics or anything. It's to give it some springiness in all directions so it'll conform to your shape. And that's going to be especially important on rotor blades, say the X rotor format, where the blade has a twist to it. If you try and put a flat sheet of covering on it, it's not going to go on there well. So you need to ball up your covering and then unball it to get this micro springiness in it. So you'll build your structure for your rotors, like the wing structures here, and then you'll build a frame from scrap balsa. The kits have generally have covering frames that have a twist built into them, and you'll apply that film to the frame. We use Vaseline. Sometimes we'll use lip balm to apply the film to the frame, and then you carefully pull along the edges to stretch out any major wrinkles. You're not going to stretch out all the little micro wrinkles you put in, but you get the big wrinkles out of it. When you're cutting it off the roll, use a soldering iron. It tears easily, and cutting with a knife or scissors, you're going to get a torn mess and waste a lot of your covering. If you don't have the ultrafilm, the grocery store veggie bags, so go to the fruit and vegetable section, get a few of those really, really thin bags. Those actually make a pretty good covering material. Not quite as light as the ultrafilm, but good in a pinch. We like to use 3M77. You spray a light coating onto the frame that you've made, not the frame that's supporting the covering, but the frame of your rotor. And then gently place the rotor onto your stretched out covering. Knowing this, that it'll immediately stick. So make sure it's in the right place before it touches. Glue stick is an alternative, although it doesn't work great with the plastic coverings. It works better with a tissue covering. 3M77 is available at Home Depot or Lowe's or even Walmart to spray glue. Allow the cure to set the glue to set up for a few hours, and then again cut it with a soldering iron if possible. You can cut around the edges with a very sharp razor. Don't take a used razor, get a fresh one. I think a soldering iron or a medical cautery will work a lot better and less chance of tearing the covering. That's all we're going to say on building at this point. Let's move on to flying techniques. One of the basics here is that there's far fewer variables than on an airplane. There's not too many trim variables on the helicopter. Your pitch and so forth is built into the rotor on most of these designs, and it's a little hard to change. It may require you to build a new rotor, especially with an X rotor, in order to change the pitch and try that. You can try changing the center of gravity. So if you have a little bit of ballast on it to bring it up to weight, try it at the top and the bottom. See what works best. You might be surprised. Intuitively, it might make sense to have it at the bottom because that's hanging down. But try it at the top. See if it flies better that way. We've seen different experiences with that. The rubber, given a helicopter design, your rubber is your biggest variable. This year, there's no limit on the amount of rubber you can put on, but you can't just go unlimited in size or total mass of your rubber. At some point, it's going to be so heavy your rotors can't get off the ground. So there's going to be an optimum. There's two things you can adjust on your rubber. One is the width. We prefer to think in terms of linear density or grams per inch. Width might be 1/8 of an inch. The linear density might be 0.085 grams per inch. The linear density accounts for thickness variations as well as width variations. The rubber is formed about a millimeter thick, but it can vary in thickness 5 or 6%. So linear density, by measuring a given length of rubber on your gram scale, you can get your linear density, and that might be a better way to characterize width than the overall mass or the overall length. If you're measuring overall length, then it's still not completely independent from linear density or width. So overall mass might be a more independent variable than width. If you don't have the ability to strip your rubber to various widths or linear densities, then your only really variable here is your overall mass. And so once you try a nominal size piece of rubber, whatever specified in the kit, might be a 20-inch piece of rubber tied into an approximately 10-inch loop. Then try going to an 11-inch loop or a 12-inch loop, try going down to an 8-inch loop, and you're going to fine tune that to find a maximum. Then winding, we're going to find more so than the airplanes that you're going to want to wind to near the maximum turns. Maximum turns is where it breaks, so near maximum turns, and then back off the peak torque only enough for motor stick safety. You can get a lot of torque on these large motors we're running this year, and you can back off one or so winder turns, so 10 to 20 turns on your rubber, and dramatically reduce the amount of torque as well as the linear stretch of the rubber, and that might be safe for your motor stick. But you're going to want to launch with as many winds as you can get away with. Winding technique will be very important. Okay, I already talked a little about the rubber optimization. You got two parameters, the width or the linear density and the rubber mass or length. So you fix one parameter. Let's say you've got 1/8 inch rubber, so you're going to fix the width and then vary the length or mass and find your optimum with a stopwatch. Adjust your fixed parameter if you can, go to slightly wider rubber or slightly narrower rubber, and then adjust your length again until you find an optimum. Keep in mind, if you only have stock rubber, say you only have 1/8 inch rubber available to you, even that will vary in linear density due to the thickness variation. So be sure to weigh your rubber, your given lengths of rubber, and look for variation there. You might be able to tweak out a little bit more. Your stopwatch is your best indicator of whether you've reached an optimum or not. But to know which way to go, if you've got a lot of turns left on the helicopter when it comes down, you want to use wider rubber so it has more torque, or use a shorter loop so it has less mass. So too many turns, you want to go to a shorter loop, less rubber, less mass, or wider rubber to have more torque to support the mass that you've got. What's too many? It's hard to say, but I would start if you've got 10% of your turns remaining, you might want to consider going in the direction of shorter rubber. Your stopwatch will be your final indicator. Just use the remaining turns as an indicator of which direction you should go. If your helicopter is running out of turns up at the ceiling and just free falls, use thinner rubber or put more mass on it, put more fuel in the tank. Record all your parameters in the log and change one thing at a time. If you change a bunch of things between flights, you don't know which one helped, or they may cancel each other out. We already talked about rubber optimization. That's the key. The stopwatch will tell the tale. Winning takes a lot of flights. Test, test, and keep testing. You can test in your classroom. You can test in your living room. You can test in your lunchroom, wherever you can. Get as many flights, log them, change one thing at a time, learn how to wind better. We have videos on how to wind. Get help from us to improve your winding techniques and so forth. If you are testing in a classroom, be sure to test in a taller ceiling before your competition. If they've announced you're going to be in a 30-foot ceiling, find a 30-foot ceiling just for one flight or a few flights. What you want to look for there is make sure it's stable. You might be able to climb to an 8-foot ceiling in your living room, but if you're in a 30-foot ceiling, you might find your helicopter goes all over the place and you need more stability. You can try changing your CG location for stability. There may be some things you can do with the rotors. One person reported improved stability by changing the thrust angle of one of the rotors by bending the prop hanger. I don't know about that. It's just what somebody reported to me. A couple of warnings for this year. The large rotors to fit in this box means you're using large rubber, which means high torque and high energy. So I just want to mention safety. Science Olympiad does not require at this point eye protection for this event. I would strongly consider it. We're pulling these motors almost twice as hard as we did with the airplanes. Um, you probably have eye protection for some of your other events already. Let's not lose an eye. I'd strongly recommend it, especially if you're using hard plastic O-rings. Um, One coach suggested considering gloves because if the rubber snaps, it can snap your finger pretty good and leave a welt. I'm not sure I'd want to be handling the helicopter with gloves on, but that's what one coach recommended. Some of the issues with the equipment, the Gallega winder, also sold as indoor free flight supply winder in the top picture here, is a precision instrument. And there's been some reports of gear breakage on this winder at 2 ounce-inches of torque. Um, this winder was aimed at the market of precision planes like F1D, where your peak torque is half an ounce-inch, and it's may not be ideal to use for the higher torque. The yellow winders, like in the lower picture here, are suitable. They're not as high tech. I would recommend the 10-to-1, which has the white nose where the hook comes out. The ones with the blue nose are 15-to-1, and you might have a hard time turning those at the high torque as you reach the max torque on your motor. In addition to the winders, a lot of torque meters won't reach 2 ounce-inches. More than one full turn on a wire element torque meter can permanently damage the element. This is especially important on the IFFS or Gallega torque meters. Those, while they have numbers on the face of those are arbitrary numbers. And even with the heaviest element sold for that device, it only goes up to about 1.5 ounce-inches of torque. So don't ruin your equipment by using it for a higher torque than it was designed for. I believe Dave Ziegler at Freedom Flight Models recommended to me to have the kids try using hemostats to transfer the rubber. Kids were losing grip of the rubber or the O-ring when the rubber was really wound tight. And he found that by using hemostats, they got a better grip on the rubber and didn't lose their grip on it. Let's look at a little bit on flying. On the rubber winding, rubber has what we call hysteresis. That means as you wind it up, you're going to have a torque curve. That's your torque curve. That's your dotted line on the top of this graph, where the bottom is the number of turns or the amount of stretch you're putting in, and the side is your load, or it shows load here, but it could be torque. And as you wind up, you're going to be on the top curve. As you unwind, it's going to drop down to the lower curve. So what does this mean? It means if you just wind up to a launch torque, you won't get nearly as many winds as if you wind up to almost the breaking point and then back it down along the unwind curve to your launch torque. You're going to get almost twice as many winds by doing that. So stretch winding is critical. A torque meter is very important. You can get much closer to braking if you know the torque that's in the motor. You can count your winds, but you're going to get a much more repeatable operation by measuring the torque. You always want to lubricate. I use silicone shock oil to lubricate the rubber. I squirt a little bit into a sandwich baggie, drop the rubber in there, squish it around, and then hook it up to your torque meter for winding. Others use Armor All. You want to get original formula Armor All from AutoZone or O'Reilly's, and that's basically a silicone oil suspended in water. So some people will evaporate off the water. It's an easy source. I think you can even get it at Walmart. But always lubricate. You're going to get twice as many winds with lubrication as you would without, and you're not going to break as much rubber. Wind almost to braking. You can break some rubber to know where braking is and then back off of that. Don't wind quite so hard on your actual winds. But again, it's easier to know where that is in torque rather than number of winds. I mentioned stretch winding. You can see the young lady here is stretching the rubber about 5 to 8 times its original length, and then winding about half the turns you expect to reach at full stretch, and then walk in while continuing to wind. The last few feet of walk in, all you're doing is organizing the knots as they form. You're not trying to get more energy into the rubber at that point. Rotor adjustments. This is more advanced because your rotor pitch is generally built into the rotor. The X rotor, it's in the basic structure. A flat rotor with a carbon spar, such as the J&H helicopter, that gets its pitch built in when you're attaching the blade to the spar using the fixture in the kit. So making rotor adjustments might mean building a new rotor or cutting into the rotor. Is less pitch better or is higher pitch better? I think that's an area for development. You need to try, um, but it's also costly in terms of time and material. It takes time to build these rotors. So if you have time and want to explore, keep in mind the kit makers have done a pretty good job of optimizing their kits because they want to sell kits. They want them to be competitive. There is two phases of the flight. There's the climb, and then it hits the ceiling and it hovers against the ceiling. Um, if you get too low of a pitch on the rotor, then when the helicopter is moving quickly toward the ceiling, you can actually stall your blades. There's a minimum pitch you need. I think it's going to probably be in the 6 to 10 degrees at the tip. And that's for an X rotor. I really don't know on the flat rotors like J&H, but the kit is a good starting position. If you want to adjust your pitch from there, build another set of rotors with a different gauge to set your pitch and try that out. Lower pitch will allow thinner rubber, but it might flutter and be ineffective in the climb. So consider the rotor adjustments to be an advanced development project. The other advanced development would be your rotor configuration. Do you try a Chinook style? Number of blades, the blade shape, the blade pitch progression, whether it's a helical pitch or like the X rotors, or if it's a fixed pitch angle like the J&H, or something in between. That's something you can experiment. The chord of the rotors. The motor stick hook to hook length does not set your rubber. You can have rubber loops comfortably up to twice the hook to hook length. People say up to 4 times the hook to hook length on your rubber loop size. I think for kids winding, I think they're going to have a hard time getting the knots well organized with that long a piece of rubber, but easily twice the hook to hook length. So the motor stick length is not necessarily directly correlated with the rubber length, but you might play with motor stick length if you have some weight budget and see if that helps with stability or helps with duration. Fine tuning of the rubber linear density would require a rubber stripper, but it's certainly advanced technique worth looking at. And then winding technique, just improving your stretch winding, changing where you walk in, changing how many turns you get in or what torque you go to and so forth. There's a lot of low-hanging fruit in your winding technique. I'm not even sure I consider it advanced development, other than ideally you'd want to have a torque meter to improve your winding technique. That's mostly the basics of building and flying. There's a lot more to it than that, but it gives you some areas you can start focusing on. If you're buying a basic kit and have basic tools, you're going to be looking at your total mass or length of rubber on the helicopter as your primary optimization and learning your best winding techniques. If you have more advanced tools, you can vary your rubber width. You can vary your pitch angle and even your rotor setup. So there's lots of possibilities, but some of them are more advanced. If you have questions that come up, the Scioli forums are the best place to ask those questions. Keep an eye on the NIFAS website at freeflight.org. We will continue to post new materials, and especially if repeated questions come up on the forums, we'll develop resources to try and address common questions. I'll be putting together a coaches tips video shorts. These will be YouTube 90-second shorts that'll address some of the questions and concerns that come up on the website throughout the year. So with that, I thank you for your attention. I hope to see you out on the contest trail, and good luck with the flying event this year. I hope your kids enjoy it. Thank you.